everyone? Today we're going to be talking more about what we call commutative property. And commutative property is one of the properties within algebra. And we're going to use commutative property today to write an expression in a different way. So what does that mean? Let's look at this first example right over here. We have A plus B. You see that we're adding something to B. So A plus B is the exact same thing as saying B plus A. And why is that true? Why is A plus B the exact same thing as B plus A? Well, let's use a real life example into account. Let's say, for example, we're starting from a house. We come home, we're at our house, and we want to use the word commute for commutative property. We want to commute a certain distance from our house to school, right? We wanna have a different distance from our house to school, and this is our school right here. It's a very lovely school, and once you get to school, you want to come back home. Let's say 3 o'clock, right? You want to get back home. You're gonna take the same distance that you took to get to school, and you're gonna take the same distance back. So let's say, for example, this was your A, and this was your B. The distance doesn't change. The first distance was, let's say, for example, it was 100 meters, and the second distance is also gonna be 100 meters. Just because you're coming back the inverse way doesn't mean that the numbers or the distance changes. So that's why A plus B is exact same thing as saying B plus A. And let's use a real number scenario over here. So let's say 5 plus 3 is the exact same thing as saying 3 plus 5. Because 5 plus 3 is 8, and 3 plus 5 is also 8. And commutative property works within addition and multiplication. So why don't we try it with multiplication? So we have x times y. X times y can be written as y times x. Y times x and x times y is the exact same thing. The distance doesn't change, or the numbers don't change, because we're using an inverse order. So if we were to use a real life example, an actual example in numbers, what we can see is if we do 2 times 3, if we were to flip it, 2 times 3 is the exact same thing as saying 3 times 2. 2 times 3 is going to be 6, and 6 is equivalent to 3 times 2, which is also 6. So the product doesn't change. The product is the same. And over here, as you can see, the sum is the same. The sum doesn't change. Let's say, for example, we were to try this little concept with subtraction, for example. Let's say we were to have a situation where we were subtracting 5 minus 4. Well, 5 minus 4 is giving you 1. But what if we did 4 minus 5? 4 minus 5 is actually negative 1. So this difference is not the same as the difference when you do the inverse, right? When you flip it around, it's not the same. So this commutative property, right? Commutative property only actually works with multiplication and addition. So what if we were to try it with, let's say, for example, we were to try it with division, right? Let's say we were to give an example where we did 6 divided by 3. 6 divided by 3 is actually 2, right? But if we were to reverse it and we were to do 3 divided by 6, we actually get 1/2. And 1/2 is not equivalent to 2. So as you can see, that commutative property only works on addition and multiplication. It doesn't work for our subtraction and our division. So at the end of the day, what we can conclude is that addition and multiplication are within commutative property, and that for subtraction and division, it doesn't work. So I hope you guys found this video useful on commutative property, and you guys are doing your math on algebra. And definitely stay tuned for the next video.